Welcome to the second Organic 1 lab, distillation. Distillation is a purification technique based on the different boiling points of liquids which are combined. Now, each substance has a particular boiling point. Most of them have been experimentally determined, and we can look them up. Don't forget that when you have a liquid and you put, for instance, a solid solute in it, the boiling point will be elevated compared to that of the pure liquid. And the same is true most often when you combine liquids. But careful manipulation can cause the lower boiling point liquid to boil before the other. That's the whole point with distillation. So we can purify a liquid from reaction components, which is mostly what you're going to be doing with it. And we can use it also to determine the composition of a mixture, which is what we're going to do in this lab to get used to the technique. Okay. You are going to work individually. Each student is going to perform a simple distillation, and then we're going to share the information between groups of 3 of you. There's not enough time in a 2-hour lab for you to do multiple even simple distillations. Okay. First is to assemble the distillation apparatus. You're going to use a 100 ml cylinder as your receiving flask, this lab and this lab only. Any other time for distillation, you should be distilling into a round bottom flask. This is one reason why we're just using ethanol and water today, because we want to be able to keep close track of the volume of distillate. And normally that's not the case. But in distilling into an open container like a graduated cylinder, there's a small possibility for vapors to escape. Okay, so no other time do you distill into a cylinder or a beaker or an Erlenmeyer. It would always be a round bottom flask on the other end. These are water-cooled condensers, so you want to start the water flowing through the condenser pretty much evenly when you start to heat the round bottom. We're using heating mantles today, and I'll show you one here as I show you how to assemble the apparatus. Okay. You want to record the temperature when the first drop of liquid drips out of the vacuum adapter and into your graduated cylinder. And then it would be nice if we could record every 2 mLs. But the 100 ml graduateds only start at 5. So first drop and 5, and then you're aiming for every 2 mLs after that. But don't make a big long list in your lab notebook, because things happen and sometimes you miss a reading. So first drop and then 5 mLs, and then you're aiming for 7. But if the next reading doesn't happen till 8 mLs, write that down in your notebook. Continue heating until no more liquid is transferred to the receiving flask, or you have only a few mLs of the reaction, the mixture in your source flask. You never want to heat the source flask to dryness, as that will do one of 2 things. It will either bake on any impurities that happen to remain, or it will crack the glass. Outside of lab, you're going to graph your information and that of the other 2 people you're sharing with, and then extrapolate to find the percent of ethanol in the unknown. So I haven't discussed it yet, but each group, one person will be doing a distillation of just ethanol, one person will be doing a distillation of a 1-to-1 mixture of ethanol, and one person will be doing an unknown, which is a mixture of ethanol and water, but you don't know the composition of. Correct identification then of the percentage of ethanol clearly indicated in your notebook when I'm grading it over midterm is worth a complete product grade. The closer you get to that correct percentage, the more of the 12 points you will earn. Alright, I've gathered what I need to assemble a simple distillation apparatus. Once I have that done, show you how it goes together. Then I'm going to modify it to do a fractional distillation. Whenever you do a distillation, you're going to need 2 ring stands. Start with one of the ring stands and one clamp. The clamp actually is for your distillation condenser. That's the way I really suggest you start to build your apparatus. Now, many students like to test fit everything together. I don't usually see that it's all that necessary if you start with your condenser. No matter what the literature says, I find we get better cooling if the inlet and outlet are pointing up and not down. Also, you're going to want to tilt it with the male end pointing down just a little bit. The next item that goes on is your vacuum adapter. Now, in order to put the two pieces of glassware together, I need to make sure that the joint is well greased. You'll notice along the tops of the benches that there are areas set aside with blue tape. Those are for students to put stopcock grease there. And the best way to apply it is just to one finger down in it, run it straight down the male end of the glass you want to put together, and then put the female on and turn it around so the grease distributes. Now, this piece is bent down, and if left to its own devices tends to succumb to gravity. So we need one ket clip, and you'll notice that it has one small and one larger diameter side. The small side is going to go on the male end of the condenser, and the larger side is going to go on the female end of the adapter, and hold it in place so that it doesn't hit the cabinet. Okay, now almost all situations after that, the next thing you would be putting on is your receiving flask, and you would be setting the height of the distillation apparatus from that. So here I have a flask like as if I were going to distill a reaction, and here again I'd want to make sure that the adapter was greased. Turn that, and that's where I want my distillation apparatus to set. The slower I can get it, the less likely, if something falls, that it's going to break. Okay. Now, that's if we were using a round bottom flask today to as our receiving flask. We are not. So I'm going to bring the distillation apparatus condenser back up a bit. Okay. Move that out of the way right now. And I'm going to assemble the rest of the other side. So on the other end of the condenser, I need to put my distillation head. Here again, I need to grease it. One stripe of grease in and turn it around. Okay. Like that. Okay. That way, most of it is vertical, and then it allows the vapors into the condenser. Okay. Now I'm going to set the rest of this, and that's going to include my thermometer adapter. Again, grease and turn. My thermometer with the bulb right at the junction of the distillation head so that it's reading the vapors as they enter the condenser. And eventually my source flask is going to go on here. So I'm going to go ahead and grease it up. Okay. But then I'm going to take it back off again. Okay. Now, the way we're going to heat these today, and this is a little loose there, but that's okay. It can, as long as it doesn't hit anything, that's fine. So we have a variety of heating methods. We have hot plates, and we might use a water bath, but today we're going to use heating mantles. The heating mantle comes in two sizes, a small size and a larger size that I took out so you can see. Now today, because we're using 100 ml as our source flask, we're going to use the smaller size. Okay? So it comes with usually a way to hook it directly to the ring stand and then the power outlet. Okay? Now, here again, I actually have two varieties of heating mantles. I have these old style, okay, and a newer model like this. The difference being is that the newer model has an inbuilt rheostat, and the old model has to use an external one. For the old style ones, if you don't put a rheostat in, it's going to be on all the way, all the time. Okay? And more than likely, that's going to overdo the heat that you want. Over, and we'll plug that in here a bit. And so this is the way that we're going to set the height of our apparatus today. Okay, and it looks like I guesstimated pretty good because the vacuum adapter is going to be able to drip into the graduated cylinder. Pretty straightforward. So now I'm going to set the height of my and position of my other ring stand. And the pressure of the heating mantle holding the round bottom up keeps the rest of this all together. That's why you only need the one clamp and the one cat clip. Right. Now I just have to have the water for the water-cooled condenser. Plastic, black rubber tubing. You're going to need actually 3 pieces because I'm going to ask that we share water so that we don't use so much think globally, act locally, correct? But since I'm the only one here today, water from the spigot goes into the bottom of the condenser. You should always have water in the bottom and out the top. Okay. So now I'm going to take the water out, and if there were another apparatus on the other side of the bench, I could run the tube from here to the bottom of that condenser. It'd be fine. But I'm going to run it into the sink.